Then coming to the another dependent source, that is called current dependent current source. If the circuit is having one dependent source, then how to find the maximum power transfer to the source to the load, and also Thevenins voltage and Nortons current. Okay, so this is the circuit current dependent current source. This current dependent current source, this depends upon current flow into the 2 ohm resistor, and this is called load resistor RL is connected between X and Y. Okay, so the current dependent current source gain is called 7Ix. The Ix is called current flow into the 2 ohm resistor. Then how to find Thevenin's voltage first? Remove the load, and X and Y terminals, there is a load. No? So remove the load, and the open circuit voltage is called Thevenin's voltage. So when it is removing the load, no current flow into the 2 ohm resistor, because of 2 ohm resistor second terminal is not connected into the network. That's why no current flow into the 2 ohm resistor. Okay. That's why Ix is equal to 0. When Ix is equal to 0, what is the current dependent source? 7Ix is also 0. When 7Ix is 0 means, what is the current 0? 7Ix 0 means uh, it acts as a open circuit. Current 0 means it acts as open circuit. So the circuit will be modified like this. When current 0 means open circuit, and what is the current flow into 2 ohm resistor? 0, and also 3 ohm resistor? 0, and 4 ohm resistor is also not connected into the network. Okay, second terminal is not connected. Only one terminal of the source is connected to positive, but negative is not connected into this circuit. That's why, so no current flow into the 4 ohm resistor also there 0. So only source voltage is parallel to the Thevenin's voltage. That's why Thevenin's voltage is nothing but source voltage. That's why VTH is equal to 20 volts. Understood? So first open the load, and once open, no current from the 2 ohm resistor. That's why Ix is equal to 0. When Ix is equal to 0, 7Ix is equal to 0. Current is equal to 0 means so it acts as open circuit. Under open circuit condition, no current flowing into 3 ohm resistor, 2 ohm resistor, and also 4 ohm resistor. So current flowing 0, the voltage drops 0. That's why Thevenin's voltage is equal to source voltage. That is nothing but VTH is equal to 20 volts. So this is the Thevenin's voltage. Next, coming to the Norton's current. So how to find a Norton's current? X and Y, there is a load resistor. So remove the load and short circuit the terminals X and Y like this. Remove the RL load and short circuit these two terminals X, Y. Then current flow into the short circuit terminal is called Norton's current, IN. Okay. So here node voltage is called, let us assume V1. Node voltage is called V1. And node equation V1 minus 20 divided by 4, V1 by 2, and minus 7Ix is equal to 0. This is called node equation. So by using mesh analysis also possible, but here we don't know voltage drop across the current source. Okay, that's why. So it's better to use node analysis. So mesh analysis is minus 20 plus 4 into I1 plus 3 into I1 minus I2. But what is the voltage drop across the 7X is we don't know. That's why don't use mesh. Okay. So it is better to use node analysis. V1 minus 20 by 4, V1 by 2, and this current entering into the node. That's why minus 7X is equal to 0. Ix is equal to, this is I2, and also its current IN. Ix is and IN are both are same, and this current is nothing but V1 by 2. Okay, this is called ground. That's why V1 by 2 is equal to IN or Ix. The substitute Ix is equal to V1 by 2 in this equation. Simplify, then you will get V1 is equal to minus 20 by 11. Okay, this is called node. So then what is the current IN? V1 by 2. That's why V1 by 2. V1 is called minus 20 by 11 by 2 is equal to minus 0.99. That means what is the our assumption is that downside. The current flow into the load is called downside direction, but actual current direction is called upside in this way, Y2X. Actually, we are assuming the current flow into the load is called downside, XY, X2Y, but here negative, that means negative representation is the current from Y to X. In this direction, current is flowing to the load. Okay, then RTH, how to find RTH? VTH divided by IN. VTH is called 20, and then Norton's current that is called 0.909. So 22.22. Resistance not in negative. Okay. So that's why don't consider negative for resistance. The negative is represent the polarity direction of the current only. Okay, that's why RTH is equal to 22.22 ohms. Then maximum power P maximum is equal to VTH squared by 4 times of RTH. Substitute VTH and RTH in this equation. Then VTH is called 20 into 28, 400 by 8, 4 times of RTH. Then 88.8 is then maximum power is equal to 4.5 watts. So like this we can calculate theoretically by using nodal analysis, and also by using this we can find the maximum power transfer to the load. Then how to verify this? By using PSpice schematic. Let us open PSpice schematic and then take a VDC voltage source, VDC, place here VDC, and one resistor, take a resistor like this. Here also one resistor is present, and then press controller, place here resistor, and then next current dependent current source. Okay, F is called as a current dependent current source. Place here and select and connect the terminals by using wire. Okay, like this. Connect terminals as per circuit diagram. This way. Connect the terminals, current dependent current source. Here, what is the direction of the current dependent source? Upward direction or downward side? Upward direction. That's why change the value direction of the resistance dependent source. Change the direction by press Ctrl R. So this is the current direction, upward direction. So, connect these terminals in this way. Here, connect one to load resistor, for example. Load resistor. For example, let us assume this is called load. And connect these terminals. Here, what is the current direction? Ix in this direction. Ix is current depends upon the current flow into this resistor. So that's why first change the values of what is the resist, what is the voltage here? 20 volts. 20. Save alter. Then how much resistance? 4 ohms. 4 ohms. Save alter. 4 ohms. 4. Save alter. Then okay. What is the resistance here? Resistance is called 3 ohms. Value is equal to 3 ohms. Save alter. Then okay. Here resistance is called 2 ohms. 2 ohms. And this is depends upon current flow into the 2 ohm resistor. Current dependent current source. So current entering into the source and leaving this way. Current, the direction of the current is called in this upward direction. That's why current leaving from this branch and leaving, entering into the dependent source and leaving from the. So this current dependent current source is connected in series, like series place ground. 4, 3, 2, and this is called load resistance. So then how to find the Thevenins voltage? Means by just by placing the dummy current source IDC, place here IDC, and then simulate. So right here save max. What is the voltage here across this dummy current source? 0 amps. So that is means open circuit. What is the voltage? 20. That is called source voltage. So take a point and place here. So that voltage is called 20 volts. This is called Thevenins voltage. Open circuit voltage is called Thevenins voltage. And then next coming to the short circuit current. How to find the short circuit current? Short circuit current, remove this, place one voltage source VDC, 0 volts. 0 volts means short circuit. Then simulate. Press I. Okay. Here, what is the gain of the? So there is some mistake. So gain is not changed. That's why. What is the gain of the circuit? Gain. It's called 7ix. No, that's why. Right here. 7ix. 7. Open this current source. Right here. Gain 1 instead of 1. Right. 7. Save alter. Then okay. And simulate again. What is the current? Down, yeah, 909.09 milliamps. So that is called 0.909. So our theoretical calculations, according to our theoretical calculations, what is the current? So current, that is called Norton's current. Ix is equal to In is equal to minus 0.909. So our direction is called x to y. It's called positive, negative, and y to x is positive. And here was, let us check the what is the direction of the current. So upward direction. Okay, that's why 9.909. So we got theoretically minus. Okay. So in this way, we got to find the Thevenin's voltage and Norton's current. Then coming to the how to find the uh, maximum power transfer. So remove this, place one resistor. Okay, plus controller like this place. And the value of the dependent this resistor, load resistor value is equal to, right, in this terms of flower brackets, RL, capital RL. Okay, RL is our name of this load resistor is called RL, variable resistor. Go to analysis, go to analysis, setup, DC sweep, enable DC sweep, open DC sweep, select that is called global parameter. What is the name of the global parameters? RL, starting value 0.01 and end value is called, for example, Thevenin's resistance 22, no? That's why 80, for example, 80, and the value is called 80, and next increment by 0.01. Okay, then close and take one parameter, place here, open this parameter, name of the variable parameters called RL, save alter, and then next value is called value, for example, value is any value, for example, 30. Take any value like this and then simulate. Okay, so while simulating, automatically display this graph, blank graph without any waveform. It will be displayed like this blank graph, and this is called load resistor 80 up to, it shows maximum resistance up to 80 because of our end value is called 80, na? So that's why load resistance is graph will show up to 80 ohms. And go to trace, add a trace right here. What is the resistance? I think R5, R5. Okay, so that's why right here trace expression IR5, I square R means IR5 into IR5 into RL like this. I square RL. Okay, so Just check the again settings. Here, this maximum resistance that is called load resistance is called 58.51. That is 22 point. Okay, so 22.010, that is called load resistance. At that point, we will get maximum power. So Thevenin's resistance is called 22.22. So like this, we can verify the Thevenin's resistance, Thevenin's voltage, and also Norton's current. Okay, this is about Thevenin's Norton's theorem. And here we were this by using maximum power transfer theorem, so we can find the Thevenin's resistance. Theoretically, practically, so that is called 22.010. Okay, then theoretically we can get the power from what is the power transfer to the load, theoretically only from the circuit. So 4.5 hours we will get like this. This is about Thevenin's Norton's theorem.